Hi Year 7s, today we're doing some further work in algebra. We're having a look at tables and rules. Just a quick recap of what we did last lesson. We were looking at spatial patterns, so patterns made out of matchsticks, such as these ones, and we were looking at the relationship between the term number and how many matchsticks were required. And to do this, what we did was we counted the matchsticks and we placed our answers, our results, in a table of values. So here's one that's been produced, a table of values for these diamonds. And we can see that in term 1, when there was 1 diamond, we needed 4 matches. In term 2, where there's 2 diamonds, we can count them up, we needed 8 matches. And in term 3, where there were 3 diamonds, we needed 12 matches. And so we can see that for each extra diamond, we need an additional 4 matches. So we can say that for 4 diamonds, we must need 16 matches. From our table of values, what we wanted to do was come up with a rule. And we can see that in this table of values, our number of diamonds, our term numbers, are going up by 1. So therefore we can check what our number of sticks is going up by, and we can see that it's going up by 4. So we know that in our rule we must have times 4. That must be what's happening in our rule. So let's check if that works. So when I put 1 in, 1 times 4 is 4. Well, that works. Let's check with the next one. 2 times 4 is 8, and 3 times 4 is 12. And instead of using the number of diamonds, we were saying D, or we might have said T for term number, and we would have used the letter S for sticks. And creating our rule, we would have said S is equal to the number of diamonds times 4. And we know that in maths we always put the coefficient before the pronumeral. So our number of sticks equals 4 times the number of diamonds. In our work today, we're going to use the words output and input in our rules to begin with. Let's have a look at these examples. So in example A, we can see we're given a rule, and our rule says to get the output, it's equal to the input take away 2. So for each of these different inputs, we're going to put them into the rule. So our first one, our input of 3, so our output is equal to the 3 take away 2, which is 1. When our input is 5, our output is equal to 5 take away 2, which is 3, and so on. And so we can fill in the rest of the table. Let's do the same for the next rule. So over here we can see our output is equal to 3 times the input plus 1. So let's fill in the table of values using that rule. So when our input is 4, 3 times 4 is 12, plus 1 more, 13. When our input is 2, 3 times 2 is 6, plus 1 is 7. 3 times 9 is 27, plus 1 is 28. 3 times 12 is 36, plus 1 is 37. And 3 times 0 is 0, plus 1 is 1. Let's have a look at finding a rule for these tables of values. So having a look at this first one, I can see my input and my output numbers. I'm going to also call my input X. And I'm going to call my output Y. I'm going to do that for the other one as well. Okay, first I need to check that my inputs are increasing by 1, and they are. So I check what my outputs are increasing by. And in this case, they are also increasing by 1. So I know in my rule there must be times by 1. So let's double check if that works. 3 times 1 is 3, but I've got 12. So what must also be in my rule? think there also must be a plus 9. Let's look at the next one. 4 times 1 is 4, plus 9, 13. 5 times 1, 5, plus 9, 14. So I can say for my rule, output equals input times 1 plus 9, which I can also say y, because that's my output, equals input, which is x, times 1 plus 9. And I know if I'm timesing anything by 1, if it's got a coefficient of 1, then I don't need to write it. So I can say y equals x plus 9. Let's have a look at example B. So again, I check that my inputs are increasing by 1, and they are. So I check what my outputs are increasing by. This time they're going up by 7. So I know in my rule there must be times by 7. Let's see if that works. 1 times 7 is 7, which is true. And 2 times 7 is 14. So there's nothing else happening in my rule. There is no other plus something or subtract something. So again, I can write output equals input times 7. And using algebra instead, replacing the word output with y and the word input with x, I can say y equals x times 7, and then I'm going to rewrite that as y equals 7x, because I know the best way writing algebra is to put my coefficient before the pronumeral. Let's have a look at this last example. It's a little bit trickier. So here I've got my x and my y, so my input is x and my output is y. And I'm checking to see that my input, my x, is going up by 1. In this case, it's not. It's actually going up by 2. So let's double check what's happening to my outputs. My outputs are going up by 10 each time. So for every time I go up by 2 on an input, I go up by 10 on the output. So what I can do is I can divide my going up by 10 by the going up by 2, and I can see that it's actually going up in steps of 5. So if I had x value 3 in here, there would be 45, and if I had the x value of 5, it would be 55, and so on. So I know in my rule there must be a times by 5. Let's double check and see if that works. So when my input is 2, 2 times 5 is 10, but I've got 40. So what else must be happening to turn that 10 into 40? I must also be adding 30. Let's double check and see if that works with the next one. 4 times 5 is 20, plus 30 is 50. 6 times 5 is 30, plus 30 is 60. Okay, so I know my rule has times by 5 plus 30. So my output, y, is going to be equal to x times 5 plus 30. And then I'm going to rewrite that so it's written algebraically in the right format. So 5x plus 30. Okay, well done. You can have a go at some now on your own. Bye.